Mr. Weaver, it's time for science.
Mr. Weaver, it's time for science.
Young man, please come to me. Okay, we talked about the fact that everything that exists, everything, is made of stuff. And we call this stuff matter. What's it called, class?
Matter.
Matter is the stuff that everything is made of. Now, the question then becomes, what's in the stuff? If matter is everything, if matter makes up the table, if it makes up your fingernails, if it makes up the clouds, if matter makes up the mountains and the bars of gold, and the pigeon that just landed outside, if matter makes up my wedding ring, then the question then becomes, how can matter look so different? It looks so differently in this ring than it does in this book, but it's still stuff. Does anyone know how that happens? How is it that stuff looks so different? If you think you know, raise your hand. If you're absolutely and totally clueless, give me the thumbs up. Fantastic. My quest is to end cluelessness in all its many forms. So, there was an answer. You see, the stuff takes different shapes. It has different compositions. Listen to the word, class. Compositions. It has different compositions. Now, that's important. Later on, I'm going to come back to this word. Well, there are unique kinds of stuff. There are unique kinds of matter. And these little pieces of matter are pure. Meaning, if I take this book and I keep cutting the book in pieces, and in half, and in quarters, and in eighths, and in sixteenths, and in 30 seconds, at some point, it's going to stop being a book. It's going to be something else. Does that make sense?
Yes.
For example, if I take my wedding ring, and it's made of gold, and if I start chiseling it down and cutting it in halves and quarters and eighths and sixteenths, eventually it will no longer be gold. It'll be something else. I don't know. But as long as it's still gold, the smallest little piece of it, that's still that thing, it's still gold, we call that one of the stuff pieces. But we have a name for it. This stuff piece, this unique thing that can't be broken down anymore and still stay what it is, we call these things elements. Now, I could come up with a fancy definition for elements, but given the fact that you're kids, and kids are pretty smart, if you had to come up with your own definition for elements, forget the science book for a second, what would you call an element? Would you call an element a hippopotamus? Would you call an element a thing that goes around the moon? That's not really what we're talking about, is it? No. An element is something that when you cut it, how would you define an element? What would you say? Anyone want to take a guess? Yes, ma'am. A basic substance. You have no idea how much you rock. Yes! A basic substance. Now, why did you say basic? Can anyone echo what she just said? Yes, sir.
It's one thing.
How many things?
One.
So to be an element, it must only be one thing. One thing. So if, for example, I had gold and I had copper together, that's not one thing. Right? That's two things. So we better come up with another name for that. But when we're talking about elements, we're talking about one pure thing. If that makes sense, give me a thumbs up. Well, we have a list of these pure things. A very special list. A list that takes all the stuff that we know of, there may be more stuff, all the stuff that we know of, and we organize it according to what's in the stuff. The list is pretty. The list is cute. The list is absolutely amazing. We call this list the list of stuff. Does that sound right? No, it doesn't sound right. Well, we do have a fancy name for it, but, between me and you, it's the list of stuff. This is the list. We call this list, listen, I'm going to whisper it out. If you're not listening, you can't hear the whisper. It's called the periodic table. I'll say it one more time. It's called the periodic table. What's it called, class?
Periodic table.
The periodic table. Now, if you notice something, the periodic table has different colors. What colors do you see here?
Orange.
Yes, ma'am. Give me one. Orange, quiet hand only. Someone else. Yes, sir.
Blue.
Blue. Are you sure you see blue?
No,
Purple? Look more closely. What do you see? Son, if it's blue, it's blue. Don't let me talk you out of it. You see what you see. What color is it? Yes, blue. It's okay. Yes, sir.
Green.
Green, let me check. Yes, green. Yes. What else? Yes, sir. Purple. Are you kidding me? Purple on the periodic table?
Yes.
Yes, you're right. Anyone else? Anyone else? Oh, I'm sorry. Yes, sir. Magenta. Purpley kind of, sort of. Okay, all right. Magenta, fine, okay. Now, I wonder why they have different colors. This is the list of stuff. But why do you have the stuff in different colors? Well, I'm going to try today to explain to you why they're in different colors, what's the difference between the different pieces of stuff, and how this stuff builds bigger things. These things are called elements. And when I take little atoms or little pieces of this stuff, I can make bigger stuff. I like to use the example of Legos. I told you the other day that we use Legos the same way, right? Listen.
Yes.
When we're using Legos, if you've ever used Legos before, raise your hand. Awesome. If you ever use Legos, you will notice that underneath the Legos, they have these little dots. And these dots allow us to connect them like this. And so you can take 2 or 3 of these green ones that have a certain amount of dots, and you can stack them up, and you can combine them with others, and before you know it, you can make a creation. Right? Hello, that makes sense, right?
Yes.
Okay, well, what if I took all the ones that had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All the Legos that had 10 dots, and I put them in a stack. And then I took all the Legos that had 22 dots, and I put them in another stack. And I took all the Legos that had, oh, there's another 22. It goes in that stack. Ah, my favorite Lego. 2, 4, 6. Now, these have the same number of dots, but one's a little bit thicker. See? So let's imagine that these are like shells, and that there's 10 here and 10 down, so let's call this one 20. Different shells, I said. So I could take this whole bag of Legos and organize them according to dots. And I could make a big chart with colors, and all the reds have 1 dot, and all the blues have 2 dots. You see what I mean? Or maybe, oh, here's one. Listen, do you know? Now, if you really know how to play with Legos, you'll know this. Things that are thin like this, you kind of have to use them a certain way. Stuff that's wide like this, it's a little bit easier for you to balance stuff on. You can put your wheels down there. I mean, really, if you're going to really think about it, Legos is just like the periodic table. Because a Lego has certain characteristics and properties that are unique from other Legos, and just like the elements. So, well, Mr. Weaver, I get that. I can organize them into different colors based on how many dots I have. Aha! That's what we do with this. We organize the periodic table by how many dots its atoms have. Dots? We don't call them dots. We call them protons. Concentrate after me. Protons. So if an atom has 1 proton in its nucleus, we call it a hydrogen atom. If an element or an atom has 6 protons in its nucleus, we call it carbon. What's it called, class?
Carbon.
Take your fingers and make the number 6. And I want you to move them around like they're alive, because all living things have carbon. All living things have, dinosaurs had carbon. Plants have carbon. Fungi have carbon. Monarian have carbon. Protists have carbon. Animals have carbon. Even little boys and girls have carbon. Even mean old teachers have carbon somewhere in it. Carbon. All living things have carbon. Whisper that to your neighbor. So if I go out and dig something up and I analyze it using whatever tools I can as a scientist, and I take the atoms and I find out that it has 5 protons in its nucleus, was that thing ever alive? No. Because all living things have to have what?
Carbon.
All right, so here we go. So, Mr. Weaver, I know that the stuff is called elements. Or the matter is separated into these little things called stuff or elements. I also know that we can build things using these Legos. We can compose things. We can create things. Everybody take your hands and go like this. Come on. Louder, please. Louder, please. Louder, maestro. Yes, yes. That music that you don't hear. Listen, this is what a maestro does or a conductor does for music, right? It's because he is directing a composition. You, man on the piano. You, lady on the violin. You, man on the string instrument. I want you all going like this. We're going to make a composition. When things work together in harmony, it makes a composition. And so, things can be built or composed using these elements. The same way a conductor directs an orchestra to play a composition. In science, we can take pieces of these elements and we can make a composition. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Give me one of those and 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 one of those. I'll take a blue Lego and a red Lego and a blue Lego and I've got water. Huh? If I take one hydrogen atom and I take another hydrogen atom and I take one oxygen atom and I put them together and I make them bond. There are lots of different ways for the bond, but if I can stick them together some kind of way, then these three atoms will make something awesome. How many H's do I have, class?
2.
How many H's do I have, class?
3.
How many H's do I have, class?
3.
Show me with your fingers how many H's you see here.
2.
I see 2. How many, class?
2.
2. So I'll put 2 down here. That makes sense, doesn't it? How many O's do you see here, class? Show me on your fingers. 1. So I'll just put 1 here. Now, scientifically speaking, if I write this in scientific notation, it seems pretty simple. H2O simply means I have 2 atoms of hydrogen and 1 atom of oxygen. If I had 2 oxygen atoms, then maybe I'd put H2O2. Make sense? But since I only have 1, I'll write it like this. And guess what? When I take 2 of these and 1 of these and I stick them together, I got water. You ever heard of H2O?
Yeah.
That's water. That's what water is. So if I tell you that all things are composed with these elements, with these atoms, with these different Legos, with different numbers of protons in their nuclei, if I tell you that, that means that scientists can build different things using different elements. It means that we can separate things into their elements. Is anybody lost? If you're lost, raise your hand. If you understand what I'm saying, raise your hand. Okay, just check. Now, let me show you how this works. First of all, here's 1. 1, 2, 3, 4, 5, 6, 7, 8. It has 8 little dots here. If this were an atom, we'd say it has 8 protons in its nucleus. And because it has 8 protons in its nucleus, that look like this. 1, 2, 3, 4, 5, 6, 7, 8, these little charged particles. And of course, when you have 8 protons, you also have to have something to balance it out. You have 4, 5, 6, 7, 8. 8 neutrons in there also, and you've got some electrons flying around, but that's at the less than 8. If you've got 8 protons in the nucleus of an atom, that means that I take my chart and I look for the element whose atoms have 8 protons in its nucleus, and I find out that it is, what, sir? Oxygen. That's what makes oxygen oxygen. It has 8 protons in its nucleus, and we have a name for that. The number that you see there, We call it, listen very closely, its number is called its atomic number. Type it after me. Atomic number.
Atomic number.
Again, atomic number.
Atomic number.
The atomic number for oxygen is 8. Does anyone know the atomic number for carbon? Does anyone remember? Think about what I've just told you. Carbon. All living things have carbon. How many protons must be in the nucleus of a carbon atom? Do you know? Do you know? No. That's oxygen. Yes, sir.
2.
No, not 2. 2 is helium. All living things have carbon. It has to have at least 6. 6. Carbon has 6. 6. So how many protons are in the nucleus of a carbon atom? 6. Class, how many protons are in the nucleus of a carbon atom? 6. Class, how many protons are in the nucleus of an atomic atom?
6.
A carbon atom. 6. Let's try it again. Class, how many protons are in the nucleus of a carbon atom? 6. Class, how many protons are in the nucleus of a carbon atom? 6. Class, how many protons are in the nucleus of a carbon atom? 6. Class, how many protons are in the nucleus of a carbon atom? 6. All living things have carbon. Now, Mr. Weaver, this is all fine and well. I can build water with this stuff, this list. Do you understand that when you're a kid, you are a scientist? I'll show you. My son just turned 5. He is a physicist. He is a chemist. At 5 years old, he understands the basic principles of physical science. He understands that you can take things and compose something new. For example, if we were in math, we would call this number a composite number because it's made from 3 and 2. These are like the elements or prime numbers, and they build something new. 6 is a composite number. The other pieces, the Legos, the elements are the prime numbers. My son gets it. He understands that if we're talking about us light, that if you take, or color, that if you take red and you take blue, those are primary colors. Primary, original, can't be broken down. But if you put them together, you can compose purple. He gets it. And so because he gets it, he digs in his little box and he creates things. Some things I understand, some things I don't. I took this, I snuck in his room this morning and I snuck this off the shelf. Oh, I broke it. I hope I didn't fix it. And I took this from him. He took some of the Legos and he built this car with a little jet ski in the back. And in his mind, I don't know how he does it, but he's 5. He gets it. He gets it. Listen, if you were playing with atoms, they'd pay him hundreds of thousands of dollars. He's practicing. He's practicing. And so when I see him doing this, you know what I say? Attaboy. Attaboy. You keep on doing it. And some things are cool. He says, Daddy, look at my truck. I said, oh, man, that's a cool truck. And then later he'll go in and he'll build something like this. I really don't know what it is. I think I broke a wheel off here or there. Quiet, please. But he'll say, Dad, there should be a wheel right here. It has a light, and it flips around like this. And these things here get trucks or fish. And this thing is a magnet. And in his creativity, he uses the pieces to create all manner of things. He understands the basic principle that you can compose anything if you've got the right Legos. And science is the same thing. Everything is made of matter. The matter is broken up into these elements, these pieces. And with those pieces, you can build everything. As a matter of fact, this is made of elements. And so am I. And so is your nose. And so is your hair. And so is the clouds. And so are your shoes. And so is your chair. Take your hand and go like this. You feel that on your hand? You feel that on your hand? That's made of elements too. There are atoms brushing against your hand. It feels good, doesn't it? Claps go like this. You feel that? You feel that? You're pushing atoms against your face. Okay, that's enough. Stop. This, it may seem silly to you. It's just listen. Listen to me. Nobody said school had to be boring. If you're a kid and you like playing with Legos, do you understand you're already a scientist? They just don't pay you for it yet. Instead of using these, start studying the elements. Start studying the periodic table. Figure out how you can put them together and what combinations they make. Do you know that sometimes in science, these things come in 3 different states? Sometimes they're solid, sometimes they're liquids, sometimes they're gases. There are even 3 more. Einstein came up with another one. Then you have the ones kind of like Jell-O. Then you've got plasma. They don't even put that in the books because they figure most people don't like playing with Legos enough to even care about that stuff. He said, I do. So do I. Man, listen, if they could pay you hundreds of thousands, man, forget the money. You would just have fun doing it. You go to work, they have a laboratory set up with telescopes and microscopes and electron microscopes and this and that and all the latest technology just for you to play with these atoms that come in all these categories. To separate the metalloids from the non-metalloids, to change states from solid to liquid to gas, to build new things, to break things apart. And they will pay you for this. They'll give you title, masters of so-and-so and doctor of so-and-so, and all you're doing is the same thing you've been doing since you were a kid. But be careful, somebody might say, that's not cool, you shouldn't do that. Be careful. They'll talk you out of your Legos. Does that make sense? Class, if you understand, raise your hand. All right? One last thing. One last thing. How do we identify the physical characteristics of matter? Yes, particles are very, very small. So I know you can't run around, tasting and touching atoms. Well, you do, but you don't know what they're so small. But when we do have something, for example, this book. I'm changing gears a little bit. I'm done with that. Something like this book. How do I know it's a book? What are the physical characteristics of this book? If I close my eyes, if I go like this, and I feel it, I know it's a book. I can rustle its pages past my ear. I hear that. That's a book. I can smell it. Smells like freedom. Smells like freedom. Let me try it again. A book. It must be a book. It smells good. It smells good. And so listen, we identify something's physical characteristics. We know what something is by its physical characteristics. If it bounces, we can hear it, we can see it. How do you know, if I close your eyes, how do you know if it's an apple or an orange? How do you know? Yes, sir. Yes, ma'am. The shape, yes. Shape is a physical characteristic. Yes. What else? Yes, sir.
That an apple is smooth and an orange is like rough.
He said an apple is smooth and an orange is rough. Yes, that's called texture. By the way, this is bonus. I finished my lesson. I'm just throwing this in. I got 5 minutes before lunch. Yes, sir. Color. Yes, what else? What else? What else? What else? Yes, sir.
So when apples have that thing to hold it.
The stem.
Yeah, it don't have that.
Okay, so can I say shape? Because it has that shape of that stem, and the other one doesn't have that. Okay, anyone else? Yes, sir.
When you feel the orange, then it's orange.
Okay, so what's inside of it? What it's made of on the inside? Okay, anyone else? Yes. The smell. You can smell an orange. At least I can. What about this one? Taste. Just bite it. You will know that it's an orange. That makes sense? Let's say you, class, take your finger like this. Everybody take your finger. Close your eyes. And hold your finger like this. Now, how would you know if I put something on your finger? How would you know what it was? Let's say that it's after lunch. Let's say that you had a booger on your finger. Now, how would you know it was a booger? How would you know? Your eyes would have to be closed. How would you know? Could you hear it? Could you smell it? You could kind of roll it in your fingers a little bit and touch it, right? You say, you know what a booger feels like. You do. So you can roll it. Some of you might even taste it. And you would know, yes, I know that's lunch. That's a booger. Yes. There are ways that we identify matter We identify things by its physical characteristics. Class, repeat after me. Shape. Color. Taste. Texture. Smell. There are 3 others. We won't get into those right now. Let's do that one more time. Taste. Color. Smell. Texture. Color. Oh, get over it. So there's 2 things today. 1, matter is the stuff that's all around us. We organize matter into these categories called elements. What are they called, class?
Elements.
We organize the elements on a chart called the periodic table. What's it called, class?
Periodic table.
Let's start over. Everything in the world is made of matter. What's it made of, class?
Matter.
Right, matter is the stuff. And we organize that matter into things called elements. What are they organized into, class?
Elements.
And we take those elements and we organize them on a table called the periodic table. What's it called, class?
Periodic table.
Right. And based upon the number of protons in the nucleus of each atom, we know the atoms or the element's atomic number. Don't say it. And with these different kinds of atoms and elements, we can build anything. We can build water. We can build hands. We can build robots. I hope you're listening. We can build books. We can build windows. We can build cars. But you know, I haven't really made a person lately. I probably could try to make a person, but I don't know the combination of atoms to make a person. And even if I were able to build it, I'd have to jump it with an electric cord to get his heart pumping. That's beyond my capability. But I can build other things, like water. And if I boil that, I can change it and make it steam. I can build other things. Some things occur naturally, some things as humans we can create. But the point is that you as students must not fear the periodic table. You cannot be an academic punk because you are scared of something new. It's the same as when you were 5 years old playing with Legos. If you understand that, raise your hand. You say, Miss Weaver, well, why do they make it sound so hard? Because somebody's got to work at McDonald's. And maybe somebody see that and they'll get scared and say, oh my, I don't want to do it. But as long as you don't bow out like that, you're in the game. Does that make sense?
Yes.
Please, ma'am, please, sir, stand quietly behind the chair. On